Hello, welcome to another YAGSL tutorial. We're currently in 3481 Bronkbot's shop, and I'm here. This tutorial is partnered with.
Hi, I'm Aiden. I'm the lead mentor for Team 3561, the Robo Raiders.
And I am Isabella, programming captain for Bronkbots 3481, and we're going to be showing you how to configure our Swerve drive. Before we can really do anything on your robot, we're going to first have to open our configure template, or configure files template, which we go onto the YAGSL docs. We're going to scroll down to bringing up Swerve, and then we are going to go to our first configuration, scroll down, and then we are going to go click on this link right here. And this will bring us to the configuration webpage. If you want a more in-depth tutorial on what every module or every section here is, I recommend go checking out the first video, as this video is going to be primarily focused on what you need to get out of your robot in real life, how to invert your motors, set your absolute encoders. But if you need a step-by-step tutorial on, say, plugging in all your gear ratios, your IDs, then I recommend going to the first tutorial, the part 1 of the series. So let's do the first two, and then we're going to cut back out to real life us. I'm going to put pigeon here, and then so this is your IMU type. This is going to be what type of gyroscope we have. Pretty sure they have a pigeon 2. I'm going to assume so. Be 0, and then this should be good. When to invert, check the YAGSL docs for if you need your gyroscope to be inverted. We're going to go to our module properties here. This is really important, as if you do not have your gear ratios and drive ratio in place, you will break your robot, or it will break everything. So optimal voltage is going to be 12. Our robot weight, this is going to be used for simulation, so technically you don't need to measure this out. It's going to keep all of this the same. And then for our gear ratio, they have talons, or their modules use talons, I think. So their gear ratio is 4.125. Their angle, their wheel diameter is, they actually didn't tell me what their wheel diameter is. I'm gonna assume it's 4. Their diameter here, or actually no, it's 3 inches. 3 inches. Their drive gear ratio is 1.13. I'm going to put 0, and this is their module properties. The module properties done. To get the angle and drive gear ratio, there's multiple ways you can do it. You can get it from where you bought it, or if you go to yagsl.com or YAGSL docs, and then we are going to go to, there's a page for, let's see, standard conversion factors, and this is for one of the more the modules you would see. If you have, they have like a list of modules, so if you use the MKL, they have like a standard conversion for a bunch of the common modules, although if yours isn't listed on here, you're gonna have to get that from basically where you're purchasing your modules from. So here's this would be your angle gear ratio, this is going to be your drive gear ratio, and this is going to be your wheel diameter, here's your angle gear ratio, your drive gear ratio, and then your wheel diameter. Start your configuration, make your configuration files for your Swerve drive, and how to measure out all your modules. So currently, the first thing you have to do is measure side to side from the middle of the module to the other module, and you want to find the side length of that, and then you're going to divide that by half, So this one's 28 divided by 14.
Yes.
14. So 14 inches would be how far these modules are away from the center of the robot. So you take the center of this, and then the center of this, and this is usually where your modules are. So now you're going to put that in your new configuration files. If you need a more in-depth tutorial on making this, go to part 1 of the series, or one of the tutorials will be linked. So now he's going to measure the Y location. Where's your front of the robot? Right there. So this is the front. So this is going to be the positive X direction. And then over here, this is going to be positive Y. So this is the front left motor. Front left motor. This is going to be positive 14 and positive 14X, positive 14Y. This back motor would be like negative 14, negative 14X, negative 14Y. This is going to be a great time to mention that you should probably physically label your IDs in person, as you're going to be looking at them constantly while you're creating your config files, as well as later on when we need to do our 8 steps, or if you have to. This is going to save you a great deal of hassle, as you're going to have to switch around all your IDs, and it's better to just have them physically labeled. You can check what your IDs are labeled on using either Phoenix Tuner for your modules, or you can use your Rev hardware client for your Rev Spark Maxes. One way to get IDs for your modules is to look at your Rev hardware client. You're gonna plug it into where? Your Spark Max?
Yes.
Yes, Spark Max, and then where would you see that? Right there. Your CAN ID will show you right there, and then you do that to literally you put it in to your configure wire, that website, which you can find on the YAGSL docs link, pretty sure, yeah.
For our angle motor, we're using a Neo 550 run through a Spark Max. So we're gonna specify that in our configuration.
Yep.
And check for the ID.
Angle motor ID, which
we can see the Rev hardware is CAN ID 5.
CAN ID 5. So our CAN bus, you don't have any. It doesn't need to be inverted yet.
So encoder, we're using a Canon mag.
Oh yeah.
That absolute encoder IDs don't matter if they're attached to Spark Maxes. So
okay, yeah.
100.
100.
I don't feel safe doing that actually. I'm doing 11.
11? Why not just like have like a numeric number?
1.
I know, yeah. But yeah, but like this random big jump. Okay, I guess it doesn't matter.
Where is my
physically label your
Oh yes, physically label our IDs because you're gonna forget later.
No.
Or canvas, no, driver angle, this is Sparkflex.
Nope.
No.
So close.
5. Awesome. Angle motor ID. This one is 2. What? Wasn't the other one 2?
Gizmo,
Which
stop
one?
shedding.
This one. That one's 3 actually. Put 2 on one of them. This one.
That's, oh wait. Drive motor ID is 2.
Yeah.
Whoa, front
Drive motor ID is 2.
Whoa.
Whoa.
1, 2, 3. Which one are we not using? What number?
3.
6?
6.
6. I don't see a 6. You're being 6 now.
Oh. Yeah.
Not 67. Okay.
Don't have the same ID numbers for everything.
No, that's
a bad
Has
idea.
I been running out that the whole time?
Yeah.
Oh my god. Awful. What did you do?
This is back right.
Oh,
Wait. Left, right.
Oh.
Back right. This is gonna be. This one's 6 now. Which one's 2? You changed the drive motor.
Front left?
Front left is now 2?
Yes, front left.
Front
is
left
6.
is not 2. I haven't touched front left yet, so that's fine.
So this is
So back right is 4, and then 2. Absolute encoder is attached to SparkMax, and
13. Oh.
Yeah.
254 for luck.
yeah.
Cheesy proof luck.
And then when you do our front right, this is positive 14, negative 14. I should probably check my
Isn't it the
module.
opposite? It's
The Y is that way, X is that way.
I thought it was like X, positive X, positive Y.
Where's your where's your front?
Right there.
Positive X, negative positive Y.
Positive.
Good. Because if you go to YAGSL docs,
just do a quick test to make sure that it runs as
right? And then if we scroll down to our what is it? Scroll down to
Checking.
configuring your first motors. And then we have this awesome
pretty good.
document, this diagram here.
Everything's like the black and red though.
Yeah.
You know
Where
how to
the
paint our
front
robots?
is positive X, this was positive Y. See? Chart.
Minecraft.
Mhm.
Oh,
It's great.
positive X. Wait, positive X, positive Y?
Yeah, it's
Oh.
like a coordinate plane, but
No, I think I've been doing it wrong the entire time.
I mean, you just declare at the front of your robot that's somewhere else.
Okay, what the fuck did I do then? 'Cause at some point it was driving like correctly to what I wanted.
You just have to make sure everything else is also in your skewered plane.
Yes.
I mean, it would hypothetically run correctly, right?
Yeah,
Yeah.
just the wrong way.
Let's see, which one did you do before this? You did the
The first one.
first one, front left, positive 14, it works anyways.
Hi.
No, I told him. You can't say about
Okay, what else? Was that
Have I become
everything?
your best friend since I gave you some of my
It was
glasses
Everything else is default, right?
here. Yeah. This is
Yeah,
your
550. Wait, is it drive? That's drive.
That's
Tracking
drive.
550.
They only have
This is gonna be 6.
I mean,
This has a Neo that
7.
this one is on your actually it's labeled your 5 one.
that's why I said
5
Is that front right or front left?
front right.
Okay.
And absolute encoder type is going to be this one. No, it's attached to SmartMax. And then absolute encoder ID is just another number. Since it's attached to SparkMax, the ID doesn't matter, but you still want it to make sure it's not the same as every other motor. Should be done. And then module tuning. Module tuning is this is for your PID. You can tune these values later in your VS Studios or whatever ID you use. And then heading
For the PID values, go to the YGSL How to Tune PIDF. There are starting values for Spark Maxes and Talon FXs. Put those in.
Okay, yeah. So in the configuring here, how to tune PID, down here, it's gonna basically tell you how to do it. And starting points, you go to starting points. This is basically what values you want to start in. Put these values into your module tuning, and yeah, this should be your starting values, and then you can tune it to be more precise later. This you don't need to touch, and we're done. Press download, and you have your first config files. He's unzipping it. Random plug. Watch the second part of the tutorial. It goes through the exact same motions as he's doing here. Now he's putting his code. Put in the deploy folder. Yeah. And then you put Swerve. Paste it in. And now you have your Swerve config files into your deploy.
And now it has all your modules. Double check everything is good. Back right, back left, front left.
That's wrong.
Type Spark Max. Yeah, that's supposed to be a Kraken. Yeah, again, the habit of double checking all your types, IDs, make sure you don't have anything overlapping, and that is your config file set up. Now that you have your config file set up onto your robot, you want to check for inversions by pulling up Elastic. It should be downloaded with your game tools already and with WIP lid. Now you're gonna connect to your robot, I'm assuming. Yeah. Connect. Awesome. Add a widget. And then you're gonna add your Swerve drive widget, which in your modules, put your. You should use back left.
I'm just pulling up the
Yeah.
raw absolute encoders.
Yeah, raw absolute encoders. And
Back left.
you take the raw absolute encoders of all your modules. And this is how you're going to find your absolute encoder offset, I'm assuming?
Yes.
Yeah. Because what you want on your Swerve drive is for all the wheels, all the bevel gears to be facing the left side of the robot. So what's that look like?
Whoa.
Yeah. Where's the bevel gears on this thing? Is it this thing? Yeah, this side. This side, you see the bevel gears here? This is what you want facing on the left side for all your modules. When it initializes or like starts? Yeah.
What is that?
It's 0. Check when to invert. Open shuffleboard, spin your motors counterclockwise.
Raw.
Encoder is decreasing. We want to. So that's your front right, front left. Get your raw absolute encoder. Back left. Raw angle encoder. That was right. Now when we connect to our robot, we want to find the reading of it. Let me remember the docs on the top of my head. We want it to be increasing, right?
So raw angle encoder is decreasing. If it's decreasing, we invert the angle motor.
Every motor that's decreasing.
So for our back right, we're gonna spin this counterclockwise. And this is decreasing, so we're gonna invert that angle motor for back right.
Okay, so we're gonna invert this is the back right motor. We're gonna spin this one.
That's also decreasing.
That one was also decreasing when we spun it, so we need to true. It's spinning counterclockwise, right?
Yes.
That one's increasing.
Sounds fine.
So that one
front right. I don't know
front
what's
right.
happening front right.
Front right over here?
Yeah.
Front right, it is at 0.
That's wrong.
That is.
I think that's very much wrong.
Reason why this was not showing up is not plugged into the Spark Max. We love that. Make sure your wires are plugged in. Look, now that we get the encoder reading, and now he's going to spin it counterclockwise, and it's increasing, so we don't need to change the encoder, the inversion of the encoders. Anything in the drive motors now?
Yes. Which one was this?
Front left, right.
But then again, at the same time, everybody's a rules lawyer and tries to sweep around everything.
Front.
Yeah.
So that's your raw drive encoder angle, and now he's gonna be spinning.
I'm gonna spin this one first. Raw drive encoder is decreasing, and I believe that when we spin it, we face it the bevel gear facing us, and then we spin it.
Yeah.
So we're gonna check here and go counterclockwise. So that's increasing. So that's fine. That is decreasing.
Yeah.
Because it's becoming more negative. So we're gonna invert that and back left. Invert that drive motor.
Yeah, spin the wheel so it's like driving forward, right? Yeah.
And then we're gonna spin
Then
this
check
one.
the inversion. Is that the front left? That's
I think I mixed it
that
up.
changed the yeah. You have your front motors on the yeah.
Was it increasing?
It is increasing.
So that's fine.
So that one's fine.
Bevel gears facing left.
Make sure the back. That is not showing up in any of the numbers. Is the wire plugged in?
Riley, when's your other team pulling up?
Just be in the way. Oh, being hardcore defense isn't about pushing people or being hard.
You said you don't know?
Pull it up again.
Difficulties.
It's
Front
the
right,
moving
raw
roadblock of
drive
driving
encoder.
down around 410 at 40 miles an hour is what you want to be.
What
You
the
know,
freak?
where you have two
Huh.
people honking behind you and you just kind of know.
Oh,
That's part of the defense. Just clog up the middle.
They got much better after that because after they got scolded, they would come after everyone and actually ask them detailed questions about this rule.
What if it's the are they the same ID?
You can push the
Riley,
Oh, I'm with you.
what the hell is this pair of needle nose?
Yeah.
I remember correctly.
Oh, those are incredibly useful.
I know,
Front
it's
left
just
is
I've never
6.
seen something that would be used like the least amount ever.
What those?
Okay, front left is supposed to be 6.
Oh.
So it should be 6.
Yeah, make sure your IDs are correct.
This is 7.
Yeah, or
That
holding
one's
a nut on
7.
I
something.
mean, no, yeah, there's definitely been times where like I
And
need something that
then
looks exactly like
Front
this.
right
That's
should
why they
be
sell them in all the sets.
It's so goofy looking. It's not a-
Oh yeah, no.
front
goofy
right
looking,
should be 8.
very useful goofy, but goofy.
8.
If I recall that you printed, I think they made the semis that eventually.
And the angle should be 5.
5.
Okay. Do we need to redeploy?
Redeploy
Let's redeploy, just in case.
your code.
Oh, this is my suggested fall setup.
Do 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 do. Decode is now being deployed and now it's built successfully.
We'll check again.
We now check for readings.
I'm not taking a plane. This is actually a
Whoa.
this shaft runs
So now if we check, that is your front.
Yeah.
Okay, he just spun the front left wheel and now that was on the right side.
Opinion on all the crashes.
Front right, drive,
Velocity,
encoder.
encoder.
This is front right.
Front right encoder.
No,
I think it's the IDs. The IDs are mixed up.
A commercial
What?
jet
Yeah.
over
Switch the
Washington,
IDs
DC.
for
Front
right.
right,
The drive is supposed to be 7 or something.
They didn't have control.
front right
They did.
is
So
8.
ATC actually,
Front right is 8.
right before the crash,
I guess it's
you could
not.
hear ATC tell the helicopter, "Hey, look out for that plane."
Yeah.
And then a couple
Front
seconds
left is
later,
6.
one of the other planes said,
Wasn't
"Hey, did you
that
see
what I
the
was just
front
on
one?"
then?
Put it on 6 and then put the other one on 8.
So is it attack?
No, so it was 3 on the helicopter,
Let me do this real
and
quick
it
as well.
was a night train plane.
Oh.
And so
See, that's front right. So that's correct.
Yeah, so
Right.
the angle motors are correct.
North, west,
So it's just
Angle.
fine. That's so weird.
somehow the
I
helicopter
think you just had your IDs flipped. Now I redeploy the
It was a
code.
Blackhawk, no?
somehow.
Yeah,
yeah.
Blackhawks have incredibly good.
Yeah, they have 360 radar.
Mm-hmm.
They're incredibly good at seeing. And
Deploying.
it's not a Blackhawk isn't like a blind fly.
Yeah, no, they have 360 radar.
Awesome.
And infrared and all that stuff in 360
Yeah.
on all angles of the
Down to the ground.
But it would be essentially
Honestly, the biggest problem with figuring out your inversions and configuring your robot is going to be your motor IDs. So make sure you really have that double checked, triple checked,
Yeah.
labeled even physically on your robot.
Oh, they can, but
Okay, so now when you're spinning that, the drive motor is increasing.
That's decreasing.
It's decreasing? Oh
It's
yeah, it
neg-
is,
it's feeling more
right? Because it's
I
negative.
looked at the graph on,
So that means you have to invert your front right
and you
Drive.
could see it
drive.
jump up.
Did you see the other one?
The Philadelphia?
Yeah.
Did you see what kind of flight it was? No.
And now he's gonna.
Yeah.
This one
They were
is
going- they were,
decreasing as well.
transporting to somewhere else. That one's.
Yeah, December was a terrible month for aviation.
And now we're
10
gonna.
different.
We're kind of.
Can we stop yelling right around the recording?
Oh, I didn't realize.
Okay. Now we're gonna check our absolute encoder.
Absolute encoder, basically.
If the raw absolute encoder is decreasing, invert the absolute encoder.
Yes. So just gonna spin the wheel counterclockwise,
Decreasing.
and it's decreasing. This is this one right here.
Yes, that's right. So we're going to
Invert the back right.
Also, Chinooks also do not turn off their motors, so when you go to the back, you just have like a jet thing just blowing your face the entire time. Which wouldn't be as annoying if you're not really doing that while you're like carrying
This
increasing.
is increasing, and he's doing. That is increasing. Okay, he's doing that one.
You know what we usually call the Chinooks?
Decreasing.
It's a type name.
What's the difference between the angle and the absolute encoder?
The angle, I believe, is the relative neo.
Yeah.
Got that. I don't know if that's real.
No, well, like when you're testing it.
Fun fact.
Because wait, didn't you spin the wheel for both of them?
Yes. So if I spin if the raw angle is decreasing, you invert the motor. And
Yeah.
if the absolute encoder is decreasing, you invert the absolute encoder.
Okay.
Are your Chinook pilots. The second
So it's
best group
decreasing, right?
are your Blackhawks, and the lowest scoring ones are your Apaches.
Okay. Now
True.
we want to check the offsets. So we're
Woo!
gonna use the absolute encoders for that.
And more of the
So we're gonna
Absolute
make sure our
encoder.
bevel gears are facing straight. We recommend having a straight board that
medium ones on the smaller transport
straightens
Yeah.
it for you.
Patch you screw up, it's
I
your
don't know if we're gonna do that. Are we gonna do that?
Do you have one?
So if
No.
you suck, it's just you.
We're
Yeah.
just gonna use our
You
eyes.
guys should have done better.
I can check this one.
And which value are we looking at?
The raw
Raw,
absolute.
raw absolute encoder offset, and we're gonna. This is basically what we're gonna copy and paste into our config files.
I can't do that. 219.2.
You graduated college like 2 years ago. Yeah, like I asked for pictures and got back all of my friends.
19.3.
300.
Wow, you're gonna round.
Yep, 310. 310.0. Just 310.
310.
You were sent to close, too.
If you want it more precise, you can add all decimal points. We're rounding.
Front left.
That's
Straight
fine.
to me. 329.2.
329.2 for your front left.
AI generated.
No, it just looks like they did a really crappy job
Yeah, so
blurring
the
the
whole
trees
time
in the
you think
background.
that the game is
Front
broken
right.
because it's on the
Check if it's
front
straight or not.
line.
That's pretty straight to me.
It'll come back. It'll flood in. It's like
48.9.
48.9. 48.9 on your front right. Absolute encoder offset.
Alright.
Awesome. And that is everything configured. And as well as your absolute encoder offset figured out and all your inversions. Yep. We're done.
Yay!
Woo!
Now,
Deploy your robot code to have all these changes saved, and you're ready to program. Should we do a YAGSL hashtag plugin? What's that?
we should play.
Don't forget to
don't
post
wanna-
your Swerve success using hashtag YAGSL.
Don't forget to post your Swerve success using YAGSL, hashtag YAGSL on Instagram. Follow us on Bronkbots. as well. Do you have an Instagram to plug?
No,
No.
none that I'd rather
Oh.
keep safe from
Well,
creepy people.
Taff
You want to test
Robotics.
it? Sure. Taff Robotics on Instagram.
Taff Robotics.
Follow us.
Yeah, follow.